If your teen is feeling like chemistry just got a lot harder and suddenly has way more math than they signed up for, you're not alone. The mole is where students start to struggle because it requires both conceptual understanding and calculations, and that can be frustrating. So, this episode is part one of a two-part series designed specifically for all of my chemistry learners. At this time of the year, many students hit roadblocks with the mole and stoichiometry. So I'm breaking it down step by step. Today, we'll tackle the mole, what it is, what students need to know, and strategies to master it, because they will need the mole when they move on to stoichiometry. Then in the next episode, we'll take it one step further with stoichiometry, where we put the mole to work in chemical reactions. So let's dive in. Welcome to Teaching High School Science. I'm your host, Doc, a former biochemist turned high school science teacher and private tutor. Whether you're homeschooling your teen through high school science or teaching online, join me as I share tips and strategies I've learned over the years for at-home and online labs and activities, breaking down complex concepts and structuring learning in a way that makes sense. Now, let's dive into today's topics. Now, before I jump in, since visualizing what I'm discussing in this podcast may be challenging, I have linked my blog as well as my tutorial videos in the show notes that provide an illustration for everything I'm about to talk about in this podcast. First, let's talk about what is a mole. Well, first thoughts that come to mind may be a spot on your face or that little critter that wreaks havoc in our gardens. But in chemistry, a mole is simply a counting unit, just like a dozen. But instead of 12 things, a mole represents a bigger number, which is 6.022 times 10 to the 23rd particles. This number, also called Avogadro's numbers, tells us how many atoms or molecules or formula units are in 1 mole of a substance, just like a dozen tells us how many eggs or apples or paper clips are in 1 dozen of a substance. And since atoms and molecules are extremely small, we need a large counting unit to make chemical calculations more manageable. For example, 1 dozen eggs equals 12 eggs. We know that if we have a dozen, that means we're going to have 12 individual eggs in that dozen. And similarly, 1 mole of oxygen molecules is 6.022 times 10 to the 23rd, and that's in scientific notation, oxygen molecules. So if we have 1 mole of oxygen, 1 mole of carbon, 1 mole of anything, then that automatically means that we have 6.022 times 10 to the 23rd atoms or molecules or whatever in that 1 mole. So it's just a way for chemists to group very, very small particles like atoms and molecules into usable units, which allows us to make calculations more manageable. Just like bakers group eggs by the dozen, allowing them to make those conversions across different quantities for recipes more manageable. Now that we understand what a mole is, let's talk about why it's important. For one, it allows chemists to convert between the mass and the number of particles within a substance. It also allows us to perform stoichiometry calculations, like predicting how much of a product will form in a given chemical reaction. And also, it helps to relate lab measurements to chemical formulas. So without the mole, we couldn't measure, compare, or predict chemical reactions accurately. So it's a foundational concept that your students are going to need to master if they're going to be successful with the second half of chemistry. So now comes the part that has students really pulling out their hair, and that is what they need to be able to do with the mole. And there are 2 main things, and that is to convert between moles and number of particles, as well as converting between moles and grams. Let's start with converting between moles and number of particles. For that, they will use Avogadro's number as an equivalent statement, which is 6.022 times 10 to the 23rd particles equals 1 mole. Now, when I say equivalent statement, this is going back to their math class where they're setting up dimensional analysis. And the equivalent statement is like 12 eggs equal 1 dozen. then we can set that as a fraction with either 12 eggs in the numerator and a dozen in the denominator, or flip it based on what we want to cancel out and what we want to keep. Let's follow with the dozen for this first example. If I'm preparing a meal that requires 31 eggs in order to cover all of the people that will be attending, then I can use dimensional analysis to figure out how many dozens of eggs I need to buy. And to do that, I will begin with what I know, which is I need 31 eggs. And then I will multiply that by the fraction that will cancel out eggs and leave dozen. This is where that understanding of algebra and their math class comes in, because they need to know how to set up a fraction in order to cancel out units. And once they do that, they will cancel out eggs, leave dozen, and then they will be able to complete the calculation. Finding that they need 2.6 dozen of eggs, which means buying 3 dozen with a few eggs left over. Now, relating this back to Avogadro's number, they may be asked a question such as how many molecules are in 2.5 moles of water. Always begin with the given, which is 2.5 moles of water. Understanding that we're going from moles to molecules, they will then be able to set up their conversion fraction in a way that it cancels out moles, leaves molecules. And that is the key, helping them to understand that you begin with the given to cancel out what you don't want, leave what you want, and then follow out the math. Another thing students have a difficult time wrapping their brain around conceptually is how 1 mole of a substance relates to another mole of a substance when we're talking about mass. If we're looking at the periodic table, we'll take carbon and oxygen, for example. Carbon has a mass of 12.011, and then oxygen have a mass of 15.99. Now, 1 mole of carbon has a mass of 12.011, and 1 mole of oxygen has a mass of 15.99. Well, wait a minute. I thought you said a mole is equivalent to the number of particles. Well, it is. And these particles also have mass. Just like 1 dozen of eggs will have a different mass than 1 dozen of paper clips. So depending on the mass of the individual particles, 6.022 times 10 to the 23rd particles will weigh differently for one substance than it will for another. So we can use the mole units not only to convert between moles and number of particles, but also between moles and mass, because some of our chemical equations is going to require us to use mass. That brings me to the second thing students will need to do, which will be converting between moles and grams using molar mass. In order to do this, they're going to have to go back and grab that knowledge for what molar mass is and how to calculate it, which they should have picked up before getting to moles. They use the periodic table and calculate the mass of a molecule by adding up all of the masses within that molecule. For instance, water has 2 hydrogen and 1 oxygen. So therefore, they would need to take the mass of hydrogen, multiply that by 2 because there are 2 of them in water, and then add that answer to the mass of oxygen in order to get the entire mass of water. Now, once they have the molar mass of water, that becomes their conversion fraction. They can write the mass of water above moles, or they can flip it and write 1 mole above the mass of water. And understanding that, they will be able to solve a problem such as how many moles are in 3 grams of water. In this case, since they're given grams, when they multiply by their conversion fraction, they will have grams at the bottom, moles at the top, so that grams will cancel out. I want to take this time to remind you that I have linked my blog as well as my tutorial videos in the show notes to provide a visual of this concept that may be pretty challenging to visualize in a podcast. Now, understanding how to convert between particles and moles and grams and moles is going to be crucial for successfully completing stoichiometry problems, because stoichiometry problems may require students to use one or the other, and sometimes both, when they're predicting reactants or products. So I want to share some strategies to help your team master this. And these are techniques that I've used with my students, both in the classroom as well as my tutoring students, to help them make this make sense. The first thing is making a connection to real life counting units. I like using the dozen. They know the dozen. They understand that a dozen of paper clips is going to have the same amount as a dozen of eggs. However, a dozen of paper clips is not going to have the same mass as a dozen of eggs. So then we go to 1 mole of carbon. It's going to have the same number of particles as 1 mole of oxygen. However, 1 mole of carbon does not have the same mass as 1 mole of oxygen. And that helps them to wrap their brains around the conversions that they're going to do later with particles and grams. Second is to encourage unit analysis. In math, they often use the ladder system, which is just moving the decimal when they're converting between metric systems. That is not what they need to do in chemistry. They need to set up the problem and get used to it now so that they are converting and canceling units. That is going to save a whole lot of headache when they move into stoichiometry. And that is because the biggest mistakes I've seen in mole problems comes from not properly canceling the units. So making sure your team set up the habit of writing out their units in every step and properly setting it up so they can see whether conversions are needed. The third strategy is to start with simple conversions. Before jumping into grams to moles or stoichiometry, I recommend starting with moles to particles and particles to moles. As many different problems as you can have them do to the point of where they are extremely confident doing that. Then go to grams to moles and moles to grams, because grams to moles require an additional step, which is to calculate molar mass and then understanding how to use that in the conversions. And then once they've gained their confidence in grams to mole conversions, give them some mix sets. By this, I mean mix up particles to moles and grams to moles in the same practice set. This will require them to identify their information and then to determine what it is they're solving. And that is an important component in solving stoichiometry problems, because there often is a lot of information in the problems that students need to become comfortable with identifying. Next, have students write down the steps they took to solve a type of problem, and then have a type of problem there as an example, and then develop a flowchart from the steps that they've written down. And what this does, by having them write down the steps, they have to stop, think about the steps in order to write them down. And then when they develop the flowchart from the steps, they have to think about those steps in a different way. And that helps them to remember the processes that they must do for each type of problem. The last tip I have to help your students is practice. Practice, practice, practice. The mole is a skill that improves with repetition. So encourage your team to work through different types of mole problems to build their confidence, and a lot of different types of mole problems. And this should not just be one day. They should be coming back to this many times, because they are going to be using it at many different times throughout the remainder of chemistry. Helping them to understand that the mole is just a big counting unit helps it to make sense. Encouraging them to take one step at a time and to remind them that it's okay to struggle. Just as long as you practice, you go back and refer to your steps and you follow the process. Remember to check out the vlog and the videos for a visual and more practice problems that you can use with your team. And if your teen is struggling with how to enter this into their scientific calculators, I am linking my free guide that includes tutorial videos and instructions that can help them master their scientific calculator. Let me know if you have any questions, ideas, or other experiences that you'd like to share. Head on over to my podcast page, which you can access by visiting my website at thesciencementor.com. Then select podcast from the menu and subscribe now to the Teaching High School Science podcast for your regular dose of motivation and just-in-time science ideas. And together, let's make high school science a journey of exploration and achievement. Until next time, remember, curiosity leads to endless possibilities.